viewers, welcome back to my channel. This is John from Cloud Tech Insights. As part of the Amazon Bedrock series, today we'll be discussing the part 2 of the knowledge base creation. In this session, we'll be dealing with automated ingestion pipeline, which means if there are new documents coming in, it should automatically trigger the pipeline and load it into the knowledge base and continuously keep it updated. So that's the intention of today's session, and I'll be showing the pipeline via a Jupyter Notebook, which is on SageMaker, but again, it doesn't need to be on Jupyter Notebook. You can use Cloud9, you can use your own IDE. It's just the ease of showing and putting the right description, compartmentalizing. That's the reason why I'm using Jupyter Notebook. So let's get to the architecture. At a high level, what I'm envisioning is whenever the file lands in S3, it should trigger a Lambda or any other compute. It can be containers, it can be Kubernetes, or it can be a simple Lambda. Again, based on your job and the duration of the run, you can pick and choose the method to load the files into Amazon Bedrock knowledge base. So what it does is when the file lands into the already existing S3 bucket, it triggers and it Lambda hits the Bedrock Titan embedding model, convert the text to vector, and then loads it into Amazon Bedrock knowledge base. The Amazon Bedrock knowledge base is currently on OpenSearch serverless platform, and this would host all the latest information, knowledge, any kind of information in a vector style format. So this is where it hits the model. When the model responds to your query, it hits the knowledge base and come back with the citations, and those citations are converted into a meaningful insights and response back to the user. So let's get to the demo. This is the Jupyter Notebook, like I mentioned before. It's on SageMaker, and you can have your own choice of IDE. Let it be Cloud9, something on your laptop, etc. So why OpenSearch? I have provided all the information on how it is can handle large amount of data, how it can store the vector data, how it can do the KNN similarity search, some of the information why OpenSearch is provided here. And moving on to the high-level step on the ingestion pipeline. This notebook is I have preferred some of the Amazon or AWS sample site to get some additional info, and some of the information is I've referred and copied into this notebook with additional information. So at a high level, the step is creating the Bedrock execution role. All the roles related to the Bedrock execution, OpenSearch, and everything will be created in this session. As a first step, and the second comes the OpenSearch serverless collection. So we'll talk about collections in few seconds, and we're also talking about creating OpenSearch client and the index. Index is the table equivalent of in OpenSearch, and then uploading the documents to S3, which we have it under the data folder local. I've copied some of the quantum computing papers, 3 of them is in the local storage, and I'll be uploading it into the Amazon S3 bucket. And establishing a knowledge base, creating and managing a data source within the knowledge base. We have seen that in the console, how you can manage data source, add additional data source to the knowledge base, and then creating the sync job or the ingestion job. This is very important. We want to make sure that this is continuously updated. A lot of information can be stored, so ensuring that there is a continuous ingestion of new data will keep the model updated. And then you can test the knowledge base, executing some of the prompts and see what the response is like. And then the cleanup activity, which ensures all the components, roles, database, and everything is cleaned up so that there is no extra charge incurred. So before we get into the demo, I want to make sure that you understand the cost involved in playing with Bedrock and the knowledge base. Please understand that very clearly before getting into any of these demos. So starting with something to ignore the warning, install the required library. Then comes refreshing the kernel. So let's give it some few seconds for the library to install. So now we are refreshing the kernel. Either you can go to the kernel and refresh, or you can just refresh through this command right here. The first step, we're creating all the users related to the Bedrock. So we're creating the Bedrock agent client, and the service is AOS, and Bedrock Fine Tuning Cloud is the bucket name that I have all the, I will be uploading all the papers into. After that, now we get into the Ingestion Bedrock role. So these are the methods coming from the utility.py. So all these methods are in here with the right policies, etc. So you don't have to worry about how to generate those policies. It's already there, part of the utility.py. So once that is complete, it creates those execution roles, and moving on to the second step where we're creating the OpenSearch serverless index. And basically what we're doing here is providing the name of the index, which is the table equivalent in a relational database. So in OpenSearch we call it index, and then we provide the vector store name, and then we create the OpenSearch serverless client here. And once we build those clients, the first step we do is create those collections. Collection is a group of one or more indexes that represents an analytical workload. So we want to make sure those collections are created to store the vector data, as well as it helps for the vector search. In this example, we are creating some of the policies like network policies, access policies, encryption policies here, and then we are creating a collection here. And once the collection is generated, you can see the response of those collections, what those collections are, what are the configurations, etc. So here we are basically capturing some of those collection ID and building those hosts, the OpenSearch serverless. And this is the host for the OpenSearch serverless. Again, creating a policy for the Bedrock execution role for the OpenSearch. We're creating those policies right here. Next, we go to the vector index, creating those vector indexes. But one thing to make sure is that you read this detailed notes right here. It captures each and every line of code and why we are putting those line of code here. So here, before creating this, the step 3 index, OpenSearch client index, one thing we have to keep in mind is understand these configurations. This is very critical to understand these configuration, why we are using KNN vector, why are we using certain data types here, what are the mapping. There are two fields right here, vector and text, and these are the data types, and defining these things are important to understand. And once the configuration is set for these two fields, which is the vector and the text, then goes to the OpenSearch creation. This is where the host name is pasted, and the port is always 443, and authentication method is chosen, and then we are providing some of these information, and it takes up to a minute to create the OpenSearch. So that's why we have a sleep 60, so it gives a good 1 minute to create the OpenSearch. And this is some of the detailed information right here. You can provide all these information, the JSON, why KNN search is picked. All these information is here. Please take some time to read through these explanations for each line of code, and then you'll be able to understand why we are creating these two fields and how the data type is mentioned. Let's give it some time. So it's created the OpenSearch client. Now we're creating the empty index, and it says acknowledge true, shards true, the index Bedrock sample 315 is created. So this is how we create the index and set those rules. Once the OpenSearch index is created, now we upload these documents, which is under the data folder, to the Amazon S3 bucket. So I provide the bucket and the folder name. All this information is provided. You can have your own version of folder name. So this now the bucket has all the files for the knowledge base, and the next step is to create the knowledge base. Like I said, there's a lot of information here, the detailed information on each and every line of code, so you can refer this notes to understand the code much better. So basically we have the OpenSearch serverless configuration, the chunking strategy configurations. In the OpenSearch serverless configuration, one thing we have to note is the mapping is also provided. Like we said, two fields were created, the vector and the text in the file, and this shows how the model converts into vector field and what are the fields that will be mapped to the corresponding fields in the OpenSearch. And chunking strategies, again, the fixed size strategy is being used. We can discuss later more detail around the chunking strategy. And also providing the S3 configuration, which is the bucket name where the folder or the file will be stored. And then comes the embedding model. This is very important, and this is one of the native models supported by Bedrock that converts the text to vectors, and this vector data is stored into OpenSearch. And this is the embedding model ARN, and we are making sure we have all the configurations, the roles, etc. to create those embeddings and load the data. Okay, so there's another, we're building a small function to create the knowledge base where we are providing the Bedrock agent, and we're using the method create knowledge base and providing all these information that we discussed just now. The mappings, the configurations, the chunking strategy, etc. All the information will be provided here, and this function will be this method or function will be executed to create the knowledge base. The knowledge base is being created. We print the response. There you go. It says created on this date, and the status is creating. So we have to give like a few seconds to see what the status is like. So all the knowledge base is created. We're talking about different description of the knowledge base right here. The name of the knowledge base is here, and the status is still showing being created. And then we are also showing the field mapping right here, which is the text field, vector field, what is coming from the knowledge base to the open search, or what is coming from the Titan embedding model to the open search. So these are the mappings right here, and we have mentioned that it's going to the open search serverless. Again, so once we create, we want to get the knowledge base information here. So you get the response here, status says active right here, created says here, and what's the embedding model, all the information is provided. Now it knows what to use to parse the text to vector, and what is the knowledge base, where is the open search, all the information is provided right now. So the next step comes where we create the data source. So this is where step where we say, hey, this is the area where the files are stored, and this is the area where you have to like reach out, convert the text into vector, and store it into open search. So we're creating the data source here. So the data source is created. We are providing the S3 configurations right here, the chunking strategy. This tells you how to chunk the files into vector, and the location is where the files are stored, which we uploaded in a few seconds ago. That's created. We're creating the get data source, getting the latest knowledge ID and all these information. There you go. Now it says available, the data source is available, what time it is created, what is the name of the knowledge base that we are providing this information to. All these information is here. It's also providing the chunking strategy. This is where like the files are being chunked into smaller pieces and then uploaded into a vector. So the next step is creating a sync or ingestion job. So this is where we use the Bedrock agent client, and this is a method called start ingestion job, and we provide the knowledge base and the data source ID. So all the information or the files on the data source will be chunked and stored in, converted from text to vector, and vector eventually stored into the knowledge base. So this is the job, and then we are initiating the job right here, and job says starting, which means the job is initiated and the load is being carried out. So it takes a few seconds up to a minute to complete the job. So now the status of the job changed. The ingestion job is complete. It started with a starting status, and now it's complete right here. And the knowledge base has the latest information now. So this is a pipeline that can continuously ingest the data from the S3 bucket into the knowledge base. And the next step is we are just using the Anthropic Cloud Instant V1 to test out the model. We are providing a simple prompt saying what is quantum computing and what are the trends, and you get the response saying this is the quantum computing and these are the trends right here. And also understand that we can also get the source information and all these information capturing the citation element from the response. So the response comes with a full package with what the source is, what are the chunks that it use, etc. And there are a couple of other APIs that you can leverage, which is called the Retrieve API, which you can have more granular control, something that you can explore. I have the notes part of the notebook. And one thing to understand is the first part one was more of creating a one-time load into the knowledge base. And this is a continuous ingestion where this pipeline can be triggered by an S3 event, like loading a file can trigger this event and immediately convert the document into vectors and store it in open search, where the database or the LLM model will have information to provide a good response on. With this, I'm concluding my demo. So just to reiterate about the cost involved in playing with the demo, understand the Bedrock invocation cost, the Titan embeddings model, the open source serverless. There are a couple of components involved. Understanding this would really help you save some cost or prevent additional cost. And more series are to come. I'm working on Bedrock agents as well as fine-tuning Bedrock. So please like and subscribe, add your comments. Please let me know your thoughts or comments or any additional information required. And this series is meant to make you an Amazon Bedrock expert. We are going through different phases. There are a lot of options to or materials to cover during our session. So please provide me indication that it's interesting, and please subscribe to the channel. See you in the next video.